Hello?
Hello?
Hey, can you hear me?
Yeah, I can hear you pretty well.
Okay, perfect. So why don't you go ahead and pick whatever language you'd like to work in?
Okay, it's going to be Python.
Okay, cool. All right, so let's start with a quick little warm-up. So why don't you write me a function that reverses a string?
Okay. This is my first time doing an interview on interviewing.io, so I'll
Okay.
just wipe out what's here and
Yeah.
there. So the cheeky Python answer is that you could just return reversed string or input.
Yeah, you could do that. Although I prefer if you did the reversing yourself.
I expected much. Just change the variable name there because I think input is actually a built-in Python function. So we could do start with an empty string for character in our input. We would just prepend it to our output. And I think that you can just add characters and strings like that. Should I go ahead and run it, or do you want me to
Yeah, we'll go ahead and run it. Let's see if this works.
Okay. Okay, that seems to work.
Yep, that looks like it works. So what would be the... Sorry, go ahead.
I was just going to say I would take a look at some edge cases usually as well. Make sure it handles non-string input, none, stuff like that, which it wouldn't do so great right now.
Yeah, I mean, I wouldn't worry about non-string inputs. We can assume that whatever's if it's not a string, then I'm fine with it blowing up.
Yep.
So what would be the time and space complexity here of your reverse function?
So the time is going to be big O of n, basically looking at every character once, which I don't think we can do better than you could do it in half the passes probably if you did it in place and swapped the first and last characters, but you're still going to be order of n. And then space complexity, we're adding another variable output here of the same size. So we could reduce that to big O of 1 by doing it in place in the same string.
Okay.
So actually, we can't do that. So strings are not mutable.
Correct. So there's no way to do this in O1 space in Python because you cannot mutate a string. So you're correct on that. ON is the best you can do for space. But you're actually not correct about the time complexity.
Okay. So interesting. So I would have thought we have to look at every character once.
So you're correct. You do look at every character once, but that's not all that you're doing.
Right. Oh, of course. Yeah. So this actually isn't big O of n. So I think I'm correct that we can't get better than big O of n, but I'm incorrect that this is. Yeah. So the concatenation here is probably another n actually, because it's adding the whole string that we've created character by character to create a new copy of output.
Correct.
So
because strings are immutable.
Yeah. So one option would be we could. Yeah, Python is kind of weird for string-based interview questions, but we could treat it as a character array and basically slot each character in the correct index as we work our way either forwards or backwards. And we know, or we can get the length of the string in ON. So then we could do it in ON that way. Do you want me to code that up?
Yeah, why don't you go ahead and code that up?
Okay. Does treating it as a character array make sense to you?
Yeah, I think that's probably the right approach.
So basically, as we look at each character, we're going to want to put it into the string starting from the back. So output x equals, and might be an off by 1. Yeah, we want -1, I believe. Then output at output index c, output index minus equals 1. I think that should do it. I'll just run it, see what that does. Okay, so off by 1 errors are usually the things that sneak in here. So in this case, length of x is 4, output index is starting at 3. Right. I think we yeah, so we need to initiate this to like just make it like an empty array. Let's see if that works. And then we want to just join this back into a string at the end. Okay, so I think that should do it. We've got O of n for the length, and similar for creating the new output array. And now we're just doing a single character assignment per loop. So I think this whole thing should be O of n now.
And what would happen if you have an empty string?
So I think an empty string would
sure what would happen here. Okay, cool. So that just gives you an answer.
Still does work.
Okay,
yeah.
Great.
Yeah, it is a little.
Yeah.
The whole array multiplication thing is a little not straightforward, but.
Right. Okay, yeah, that looks good. Cool. So let me go ahead and give you the meatier problem that we're going to work on. So I want you to write a function, and your function is going to be called something called find missing, and it's going to take 2 arguments. And the first argument is going to be an array that has some elements in it. So I don't know, we'll just pick some random numbers. You can assume that they're all unique just to make the problem simpler. And it's going to take a second array that is going to contain the elements in the first array, but with one element missing. And what I want this function to return is the missing element, which in this case is 5. So you can assume that all the elements are integers.
Okay. And you said we can assume they're all unique, right?
Yes, you can assume they're all unique.
So my first instinct here is to go to hash tables, although we could also use sets in Python, I believe. So let's see. Call this full set. So I think if there's probably a very easy Python way of doing this where we could actually just like make a set of the first array, and then I think it's just like subtraction. Let me just try that, and then can also do it manually as well. Yeah, so I'm going to say that's the like super easy version, which is set full set minus set partial set. Like we could like assert that length of items is 1, turn and 0. And
I don't think you can index into a set. Could be wrong. Maybe Python has a weird API for sets, but I would assume that
think about how you. Okay. Correct.
Yeah.
Yeah. So it probably is a way to pop something out of there, but converting to a list is going to be the easiest thing for now. So that will work. It's pretty like just putting the work on Python. So I can also do it with a hash table.
Yeah, I mean, no, this solution is good. So what would be the time and space complexity of this solution here?
So converting to a set, I assume it's going to take linear time because you're basically just populating a hash table. I assume is similar to how Python implements it. So if we have like m and n as the sizes of the two arrays, those are both going to be linear, and then finding the difference I think should also be a linear operation.
Why do you say that?
So at least to do this specific problem, if we were doing it ourselves, we'd basically just be walking through the second array and removing things from the first when they match. And since it's a hash table, that's a constant operation, finding them, finding and removing them. So I don't know for sure what the full Python set difference would take, because you might have to do that walk through both of them, but I think that it would be linear.
Yeah, I mean, let's give Python the benefit of the doubt. They're probably not doing this in a totally stupid way for set subtraction. So yeah, I think you can say pretty safely that this is going to be linear. Cool. And how much space does this take?
Right. So we're going to be creating another full copy of m and n. Or basically like a hash table version, but on that order of size. And then the missing items is just going to be one extra thing, assuming that our input matches the criteria. So it would be another of, I think it's big O m plus n, or it might be big O m plus big O n. I don't remember what the specific difference between those two are.
Well, there'd be no difference between those two.
Okay.
But what is m in this case?
I guess m and n are by definition only one off, so they're basically the same. Correct. So we're talking about linear on the order of the size of either set, really. Yeah, exactly. Okay, yeah, that sounds correct. You're correct. So is there any way you think that I can do better than linear time here? Let's see. So the only way to do better than linear time would be to not look at every item. And the case where that could happen is if a missing item by definition is a number that's in the first set but not in the second. I'm trying to figure out if there's a way we can like short circuit the check from looking at either array. So in this case, it's the 5 that's missing. So if we're looking at the second array, we don't know until the very end until we've looked at all the items, we don't know for sure that there's no 5 in there. Actually, that's not true. We could sort it. If we sorted,
how long would that take to sort?
Oh, but that's n log n. That's longer.
Right.
So that doesn't work. So if it's not sorted, then yeah, we can't know for sure until we get to the very last element that there isn't a 5 in the second one. And to go through we go through the first one, we can't know looking at any item that it's not in the second set unless we've gone through that whole set. So I would say you can't do better than linear.
Yeah, you're correct, and your argument is sound. There's no way to do better than linear time here. Because of course, if there is at least one element we haven't looked at, that could be the missing element, right? If we don't have any guarantee on order, which hopefully we don't. So okay, so linear time is the best we can do here. But let's say we want to trade off time for space. So I'm very space constrained. I don't have enough memory to create a whole copy of my data set. How would you lower the amount of space that the solution takes?
So if we don't care about time at all, one option is we sort both arrays, and then you can just walk through them one by one. You sort them in place, so it takes the same amount of space. Walk through them index by index, and then as soon as you find a difference in 2 elements, you've found the missing item.
Yeah. And what sorting algorithm would you use for that?
Just we don't have any expectation given on like the specific kind of data that we're working with, so probably just go with like quicksort for general data sanity. I think that's what Python uses by default to sort data, or it might be some slightly modified version of quicksort.
Yeah, I'm fairly certain it uses a modified quicksort. And what would be the space complexity if we use quicksort?
My sorting algorithms are a little bit rusty, but I did forget that they can add extra space complexity as well, so that might be an issue. But I think quicksort is a variant of merge sort, I believe, which picks up pivot and then is just swapping items around. Oh, but it's recursive. Yeah, so it's probably bad for the space complexity. So if we really didn't care about time complexity, we could just do like a bubble sort or something that doesn't take any extra space. But I think there are also better sorts that don't take any space.
You're correct. So in particular, there is a sort, well, there are a number of sorts that are n log n time that are also O1 space, such as heap sort, which you may vaguely remember.
Yep. Okay.
Yeah. So if you use a sort like heap sort, you can get into O1 space. Quicksort would be log n for the reason you just mentioned, which is because it's recursive and so you need stack frames. But yeah, okay. So you could go look up a sort that is O1 time, O1 space, and if you needed to bite that bullet, then you could get n log n time and O1 space. So that's good. That gives us a nice different ways to approach this problem. But let's say that I need ON time, like n log n is not a trade-off I'm willing to make. Do you think there's a way that we can improve the space from ON to being less than ON while still maintaining ON time?
This requires the constraints to be fairly specific, but I think if we're guaranteed that they're all integers and they're all unique, then we can just sum up the first list and subtract the sum of the second list, which should give us the missing item, and that is a very simple algorithm. So that's just going to be linear time in constant space.
That would work. Why do you say that it's constant space?
Because we're just doing 2 sums and then a subtraction.
True, but that doesn't guarantee that it's constant space. Do you know why?
I guess because we don't know. I guess we don't know how big the sum is going to be.
Correct.
Gotcha. So like if we're dealing with very large integers.
Right. If we're dealing with very large integers or just sufficiently many integers, then
Right.
clearly the size of the sum we're going to store is in some way going to scale with the size of the input, right?
Yeah. Is this one of the things we can use an XOR as well? Is this one of the things where you can use
an XOR? How would you do that?
I think if you just XOR a series of integers and then how does this work? I'm just gonna. Is it okay if I just look up what the Python XOR function is and then can just play with it in the console for a sec?
Yeah, so it's the caret. I'm fairly certain.
So if we do 4 XOR 12, and then I think it's like if you XOR it with the same number again, it gets you back to basically like if you have any number and you XOR it with an integer and then you XOR with that integer again, it like undoes the effect. Yeah, which is like sort of tautological because it's just flipping the bits.
Right.
So I believe we actually would just XOR all of the integers in both lists. 12, 9, 5, 6, and then you just do all the other ones as well. It's feels kind of strange because I'm not even treating the two lists differently, but I believe that the end result should end up with 5. Yeah, and then that one is actually constant space because it's only an integer at any point.
Yeah, that sounds perfect. Why don't you go ahead and write that up real quick?
All right. I don't know what you would call this exactly, but XOR sum seems close enough. That's it.
Yeah, let's give that a quick run and make sure it works.
Oh, that looks good. Don't know if that would handle negative numbers.
Yeah.
It appears to.
No, it does, because negative numbers, because the way it's
finding a binary. Yeah.
Exactly, because the XOR is going to respect the negative bit. Perfect.
So you can actually use this on any binary like data type and like find a missing binary object from a list of binary objects.
Yeah, exactly. I mean, as long as you only have one of them, right? Otherwise, you would just get the XOR of the two objects, for example. Yeah. But yeah, you pretty much got it. That was perfect. I don't have anything else for you, so well done.
Thank you. How does this work from here? Like, do you have like a feedback form afterwards, or do we just like chat about it for a bit, or?
It's up to you. We can chat about it if you want, but we both get feedback forms and then we send them to each other, and then we both can mutually read the feedback.
Gotcha. Yeah. So I'm
if you
like
have any questions, I'm happy to answer them.
Yeah, I'm just like back on the job scene after a couple of years of running my own startup, and so it's been a long time since I've done technical interviews. Just like any constructive criticism or things that I could do better or work on would be appreciated.
Yeah, I mean, my feedback honestly is I think you pretty much knocked this problem out of the park. I think you're probably the fastest person I've seen solve this and get to the optimal solution. Your coding is clearly strong. Like you're familiar with Python. You're pretty comfortable, I can tell. The only thing that was like a slight irk was like calling variables X. Like that is kind of a peeve of mine. But different interviewers aren't going to care. So that's totally like it's an idiosyncrasy that doesn't really matter that much in the long run.
Gotcha.
Yeah, no real feedback. Sorry, go ahead.
I always struggle with variable naming in interview questions because it seems to be like very ambiguous quantities. Do you just have any like suggestions of like what to call a variable for like a string input, like for the reverse function, for example?
Usually I just call it str for string, just like just you know, as long as it's there's nothing descriptive of it other than its data type, then I would just name it by its data type.
Okay.
But again, like this was not nearly egregious enough for me to actually mark you down for it. Like I've done interviews where people, you know, where people are writing a fairly complicated function and they're calling things X and Y and G and things like that, which get really bad. Or they call function F, you know, that sort of thing. So yeah, like honestly, calling the input to a reverse function X is not enough of a violation that I care. So
cool.
Yeah. Overall, I'd say
okay.
You perform pretty strongly.
All right. Thank you very much.
Cool. Yeah. No problem. Take care.
You too.